Hey guys, so today we're talking about functions. So a function is a special type of relation, and that's when each element of the domain is paired with exactly one element of the range. So what that means is every output, or every input rather, has only one output. Alright, so I like the soda machine analogy. A soda machine or a snack machine, if you hit the button or the code, you only get one result, right? So if I hit the button here, I'm going to get a Diet Coke. The machine wouldn't be working if I hit this button, that's our input, and it was a mystery whether I get a Diet Coke or a Sprite or something else. All right, you can't have two options for one button. There's only one option for every button. All right, we could have something like a water machine where every single button gives you the same output. That's fine, right? So if we have a bunch of different inputs and they all give you the same output, one output, that's fine. You just can never have the situation where one input gives you two different outputs. All right, that's not a function. If one input gives you two outputs, it's not a function. It's a relation, but it's not a function. All right, so let's do some examples here. Determine whether the relation is a function. Well, you have a 6, 4, 7, and -3. All right, so they're all different x's, so they're all different inputs. So there's no way you could have one input that gives you two different outputs. So even though we have the same y a couple of times, that's fine. So let me just show you. The easiest way for me is to just look at this picture. If that happens, one input, two outputs, it's not a function. So I just kind of translate them into this. So 6, 4, 7, no, my bad. 6, 4, 7, -3. And then our outputs are -3, 1, -2, and 1. All right, so two of the same outputs, that's fine though, because our mapping doesn't do this. So we're good to go. All right, so yes, it's a function. Determine whether this is a function. Yes, it is a function because every input, the x's, has only one output, the y's. If this wasn't a function, we'd have to have an extra dot or something. So then let's say x equals 1. There's a -3 and a 2. So x equals 1 would have two y's, and that would be illegal. That would not be a function. So that's what our vertical line test. That's how we test using a graph. Vertical line test says that if a vertical line hits the graph in more than one place, then it is not a function. So you may want to pause and copy this down. Alright, so there's our vertical line test. And then determine whether the relation is a function. Well, clearly no, and it's because of this right here. Our input of 1 has two outputs, a 4 and a 5. Right? That soda machine wouldn't work. You hit the button, you get one of two different options. That's not how they work. So a few more examples. Are they functions? Yes. We can draw it like that. We don't have to worry about this scenario happening. So yes, this makes it not a function. So does the 8, having two different outputs. Input of 8 gives you a -5 or a 7. That's not a function. And then here, we'd use the vertical line test. So let's get a vertical line. Does it strike our graph in more than one place? Not once, 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 once. So that is a function. Now look at over here. Once, 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 twice. Hits it in two places. So this is not a function. So this one's yes. This one's a no ski. Because this and this, an input of 2, 1, or x gives us two outputs for the y's. So that's not a function. Alright, so here is your U-try. And then there's a couple more examples. So function notation. For some reason, this trips people up and gives people a really hard time, but it's actually wicked easy. Okay? So, for example, you can write y equals 2x minus 1 can be written as f of x. This is just notation. Alright? This is just notation, meaning it's just a different way of writing it. That's all it is. It's just a different way of writing it. So that we call our function, this is like a function name. Alright, f is our function name. So g is the function name here. Alright? That's just a different way of writing our function. And then this is just what are we plugging in. Alright, we plug in x. So any number we substitute into this function, we just substitute into the x on this side. So this is where you do stuff. This is just the notation. Alright, so this is where you do stuff, and this is just its name. Alright, think of it that way. So f of 3, that just means we're plugging a 3 into this function, into the f function, which means we substitute a 3 in here, and that's what we do. So that would be 3 times whatever we plug in. We're plugging in a 3, so 3 times 3 minus 4, which is 9 minus 4 equals 5. That's our answer. F of 3 equals 5. Plug in a negative 2. So that's going to be 3 times whatever we plug in minus 4. Alright, so we're plugging in a negative 2. So 3 times negative 2, and you just crunch the numbers. So f of negative 2 equals negative 10. Alright, so a couple more examples here. 3x plus 2. So f of x being 3x plus 2 is the same as y equals 3x plus 2. So you're just plugging in the negative 2 for the x. So 3 times negative 2 plus 2 is negative 6 plus 2 equals 4. There's our answer. Alright, so last one here. Just think of it as y equals x squared minus x. So we're just plugging in a negative 1 for x here and here. Remember, this side is the do something side. So that's negative 1 is the x, and whatever you're plugging in gets squared. So I basically put parentheses around the x in every function. That's what I was doing here. I just always do that so I keep my negative numbers correct. So minus whatever we plug in, and we're plugging in a negative 1. So negative 1 squared is 1, minus a minus 1 is a plus 1, that gives us 2. Alright, so and since we have to add 4, we have to have a plus 4 here. Since g of negative 1 is this part here, that equal 2, so g of negative 1 plus 4 means we add 4 to whatever that result was. That gives us a 6. That's our final answer. Alright, now here is your final you try. Alright, so all you got to do is plug these numbers into this. So just think of it as y equals, and then plug the numbers in and get a little answer. Alright, here you have to plug it in first, then add 1 to whatever you get at the end. Alright, here you're plugging in something with a variable, so you'll end up with a variable in the end. Alright, so this you try, and this one. See you next class.